Welcome students to the second session of chapter 2 Polynomials. Before starting the second session, I hope you have completed exercise 2.1 and 2.2. Please be regular and up to date with your homework. Okay, then we will move to remainder theorem. What does mean by remainder theorem? Let p of x be any polynomial of degree n greater than or equal to 1 and let a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. That is, when you are dividing the polynomial p of x by the linear polynomial x minus a, then the remainder is p of a. So without doing the division, you just find p of a, that will be the remainder. Now suppose if p of x is divided by the linear polynomial x plus a, then the remainder will be p of minus a. That is, you are substituting the value of linear polynomial, that is, suppose if it is x minus a, value of x is a. So the remainder is p of a. When you are going to do the rest of the exercise, it will be more clear. Exercise 2.3, question number 1. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by, in that question number 1, that is, you are dividing by the linear polynomial x plus 1. So first you are finding the value of the linear polynomial x plus 1. To get the 0 of the polynomial x plus 1, you have to equate to 0. So you will have x plus 1 equal to 0, x equal to minus 1. So when the polynomial p of x equal to x cube plus 3x square plus 3x plus 1 divided by the linear polynomial x plus 1, if you want to get the remainder, directly you find out what is p of minus 1. That is, replacing x by minus 1 in the given polynomial. So you will have minus 1 cube plus 3 multiplied by minus 1 square plus 3 multiplied by minus 1 plus 1. That is equal to minus 1 cube is minus 1 plus 3 multiplied by minus 1 square. That is 3 multiplied by 1. That is 3 plus 3 multiplied by minus 1, that is minus 3, then plus 1. So you are getting the answer as 0. Therefore, the required remainder is p of minus 1, that is equal to 0. Now, in question number 1, the second one is you have to get the remainder when p of x equal to x cube plus 3x square plus 3x plus 1 is divided by the linear polynomial x minus 1 upon 2, what will be the remainder? Then by remainder theorem, remainder will be p of 1 upon 2, that is, you are replacing x by 1 upon 2. So p of 1 upon 2 equal to 1 by 2 cube plus 3 multiplied by 1 by 2 square plus 3 multiplied by 1 by 2 plus 1. So you will have 1 upon 8 plus 3 upon 4 plus 3 upon 2 plus 1. Taking the LCM, you will have 1 plus 6 plus 12 plus 8 upon 8. That is equal to 27 upon 8. So the remainder p of 1 upon 2 equal to 27 upon 8. Same way, question number 3, that is, when the given polynomial p of x is divided by another linear polynomial p of x equal to x, then what will be the remainder? Then by remainder theorem, you have to find p of 0. Replace x by 0, you will have 0 cube plus 3 multiplied by 0 square plus 3 multiplied by 0 plus 1, that is equal to 1. Therefore, the remainder equal to P of 0 equal to 1. Now, question number 2. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Let p of x, the given polynomial p of x, equal to x cube minus ax square plus 6x minus a. By remainder theorem, when p of x is divided by x minus a, remainder equal to p of a. Now, in the given polynomial, you are replacing x by a. So, you will have p of a equal to a cube minus a multiplied by a square plus 6 multiplied by a minus a. That is equal to a cube minus a cube plus 6a minus a. Now, combine the terms which are having same power and same variable. You will have a cube minus a cube, that is 0, plus 6a minus a, that is 5a. So, you are getting the remainder as 5a. Now, question number 3. Check whether 7 plus 3x is a factor of 3x cube plus 7x. If 7 plus 3x is a factor of 3x cube plus 7x, when you are dividing 3x cube plus 7x by 7 plus 3x, the remainder will be 0. Now let f of x equal to 3x cube plus 7x and g of x equal to 7 plus 3x. It is a linear polynomial. To get the 0 of g of x, you have to equate g of x equal to 0, that is 7 plus 3x equal to 0, that is x equal to minus 7 upon 3. Now the 0 of g of x is x equal to minus 7 upon 3. Now you are replacing x by minus 7 upon 3 in f of x to get the remainder. Therefore, f of minus 7 upon 3 equal to 3 multiplied by minus 7 upon 3 whole cube plus 7 multiplied by minus 7 upon 3, that is equal to 3 multiplied by minus 343 upon 27 minus 49 upon 3, that is equal to minus 343 minus 147 upon 9, that is equal to minus 490 upon 9. That is, you are getting the remainder as minus 490 upon 9. Since f of minus 7 upon 3 not equal to 0, therefore g of x equal to 7 plus 3x is not a factor of f of x, that is equal to 3x cube minus 7x. Next, we will move to factor theorem. Let q of x be a polynomial of degree n greater than or equal to 1 and let a be any real number, then x minus a is a factor of q of x if q of a equal to 0 and q of a equal to 0 if x minus a is a factor of q of x. That is, if q of a equal to 0, then x minus a is a factor of q of x. Then we will move to the factorization of quadratic polynomials. One of the method is by splitting the middle term, or you can use the identities that you have learned in 8th standard. So how you are going to split the middle term? Suppose a quadratic polynomial is x square plus lx plus m, where L and m are constants. Now we split the middle term lx as ax plus bx so that ab equal to m. Then you will have x square plus lx plus m equal to x square plus ax plus bx plus ab. From the first two terms, take the common factor x outside. So you will have x plus a multiplied by x plus from the last two terms you will have b multiplied by x plus a. So x plus a is common in both the terms. So you will have x plus a multiplied by x plus b. Now we will move to exercise 2.4, question number 1. Determine which of the following polynomials has a factor x plus 1. Then you can use the factor theorem, that is, when you are dividing a polynomial by x plus 1, you have to get p of minus 1 equal to 0, then it is a factor. For that, question number 1, let p of x equal to x cube plus x square plus x plus 1. Replace x by minus 1, you will have p of minus 1 equal to minus 1 cube plus minus 1 square plus minus 1 plus 1. Now you will have minus 1 cube is minus 1 plus minus 1 square is 1 plus minus 1 is minus 1 plus 1. So you will have p of minus 1 equal to 0. Since p of minus 1 equal to 0, x plus 1 is a factor of the given polynomial x cube plus x square plus x plus 1. Now we will move to question number 2. Here let p of x equal to x raised to 4 plus x cube plus x square plus x plus 1. Here you have to check x plus 1 is a factor or not. For that you have to take p of minus 1. So you are replacing x by minus 1. So p of minus 1 equal to minus 1 raised to 4 plus minus 1 cube plus minus 1 square plus minus 1 plus 1. That is equal to 1 plus minus 1 cube is minus 1 plus minus 1 square is 1 minus 1 plus 1. So you will get p of minus 1 equal to 1. It is not equal to 0. Therefore, by factor theorem, x plus 1 is not a factor of x raised to 4 plus x cube plus x square plus x plus 1. Now, question number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. In that, question number 1, we have p of x equal to 2x cube plus x square minus 2x minus 1 and g of x equal to x plus 1. If g of x is a factor of p of x, the remainder will be 0. That is, first you are finding the value or 0 of the polynomial g of x. For that you are substituting g of x equal to 0, that is x plus 1 equal to 0, x equal to minus 1. And you are substituting x equal to minus 1 in the given polynomial p of x. That is p of minus 1 equal to, you are replacing x by minus 1 in the given polynomial, you are getting 2 multiplied by minus 1 cube plus minus 1 square minus 2 multiplied by minus 1 minus 1. That is 2 multiplied by minus 1 cube is minus 1 plus minus 1 square is plus 1 minus 2 multiplied by minus 1, that is plus 2 minus 1 equal to minus 2 plus 1 plus 2 minus 1. So you are getting the answer as 0. That is p of minus 1 equal to 0. Therefore, g of x is a factor of p of x. Same way you can do the second sum. We have p of x equal to x cube plus 3x square plus 3x plus 1 and g of x equal to x plus 2. So first you will find the 0 of g of x. For that you are equating this to 0. You are getting x equal to minus 2. So you are replacing x by minus 2 in the given polynomial p of x. So p of minus 2 equal to minus 2 cube plus 3 multiplied by minus 2 square plus 3 multiplied by minus 2 plus 1. That is minus 2 cube is minus 8 plus 3 multiplied by minus 2 square, that is 3 multiplied by 4, that is plus 12. 3 multiplied by minus 2, that is minus 6 plus 1. So you are getting minus 14 plus 13, that is minus 1. Therefore, P of minus 2 not equal to 0. So G of x is not a factor of P of x. Exercise 2.4, question number 3. Find the value of k if x minus 1 is a factor of P of x in each of the following cases. The first one is P of x equal to x square plus x plus k. You have to find the value of k, and it is given x minus 1 is a factor of P of x. Therefore, P of 1 equal to 0. So you are replacing x by 1 in P of x. So you will get P of 1 equal to 1 square plus 1 plus k, that is equal to 0. That is P of 1 equal to k plus 2 equal to 0. Therefore, k equal to minus 2. So in the first question, the value of k is minus 2. Same way in question number 2, the given polynomial is 2x square plus kx plus root 2. Since x minus 1 is a factor of P of x, you have to find P of 1 that will be equal to 0. So P of 1 equal to 2 multiplied by 1 square plus k multiplied by 1 plus root 2. You will have 2 plus k plus root 2 equal to 0. That is k equal to minus 2 minus root 2. You can take minus side as common. So you will have minus of 2 plus root 2. Now question number 4, factorize. In that second question, that is 2x square plus 7x plus 3. It is a quadratic polynomial. So you can factorize the polynomial by splitting the middle term. In 2x square plus 7x plus 3, the middle term is 7x. So you have to find two numbers such that the sum of the two numbers will be 7 and the product of the two numbers will be the product of the coefficient of x square and the constant term, that is 2 multiplied by 3, that is 6. So you have to find two numbers such that their sum is 7 and the product is 6. So you are getting the two numbers as 1 and 6. Its sum is 7 and the product of 1 and 6 is 6. So you rewrite the given polynomial as 2x square plus x plus 6x plus 3. Now from the first two terms, x is a common factor. So you take it outside. You will have x multiplied by 2x plus 1 plus from the last two terms you will have 3 as common. So 3 multiplied by 2x plus 1. Now in both the terms 2x plus 1 is common. So take the common factor outside. 2x plus 1 multiplied by x plus 3. So the factors of the polynomial 2x square plus 7x plus 3 equal to 2x plus 1 multiplied by x plus 3. Move to question number 3. We have another quadratic polynomial 6x square plus 5x minus 6. The middle term is 5x. So you find out two numbers such that the sum of the two numbers will be plus 5 and the product of two numbers will be 6 multiplied by minus 6, that is minus 36. So you are getting the two numbers as plus 9 and minus 4. So the given polynomial can be written as 6x square plus 9x minus 4x minus 6. From the first two terms, 3x is a common factor that you take it outside. You will have 3x multiplied by 2x plus 3
and from the last two terms minus 2 is common. So you take minus 2 multiplied by 2x plus 3. In both the terms 2x plus 3 is common. So take the common factor 2x plus 3 multiply by 3x minus 2. So the factors of the polynomial 6x square plus 5x minus 6 equal to 2x plus 3 multiplied by 3x minus 2. Now in exercise 2.3 and 2.4, the questions that we have discussed, you have to write it in the notebook and practice it, and the questions that I have marked here in exercise 2.3 and 2.4, you have to do it as homework. Thank you.